Hi everyone, we're going to solve another question on Newton's law. A 50-kilogram box is pushed up a smooth ramp with a horizontal force of 300 newtons. The magnitude of the box's acceleration is... So we're going to solve for the magnitude of the acceleration of the box. The first step is to draw a free body diagram of the object. Basically, you're going to draw all the forces acting on your object. Let me draw the ramp here again. And I'm going to put the object right on the ramp. There you go. The forces acting on the object are the force of gravity, the force from the earth acting on the object, which is a straight down, m times g. The force from the surface of the ramp, it is called Fn. This force is perpendicular to the surface acting on the object. I should note that Fn and mg, they are not in the opposite direction when the object is on a ramp. Then we also have the force of us, which is a 300 newtons force, F. So I drew the free body diagram of the object. The next thing I'm going to do, I'm going to pick an x and a y axis. I'm going to pick x along the surface of the ramp. Why? Because the object moves up the ramp. So for ramp questions, normally this is the x-axis and the y-axis would be perpendicular to the surface of the ramp, which would be along the normal force. Now the next step is to break down the forces into x and y components. If you look at mg is a straight down. It's not along the y or along the x-axis, so I have to break down mg. If the angle of the ramp is 30 degrees, therefore mg also makes 30 degrees with the vertical. Yeah? So if I really look at it like this, I want to show you this. Basically, this angle and this, they're always equal, always. Yeah. So if this is 30 degrees, the angle that mg makes with the y-axis, that would be 30 degrees as well. And also, the angle that f makes with the x-axis is 30 degrees as well, because you would have here to be 60, because 30 plus 60 would be 90, and then 60 plus another 30, that would give you 90 degrees. mg will have two components. The x component will fall on the x-axis, and it would be opposite to 30 degrees. Therefore, it would be mg sine 30. And if you remember in the class, I said sine slides down the slope. And the y component of mg would be falling on the y-axis, and then you will have mg cos 30 for the y component. Similarly, f needs to be decomposed into x and y component. The x component would fall on the x-axis. It would be f cos 30 because it is adjacent to 30 degrees. And the y component, therefore, would be f sine 30. Perfect. So I broke up my forces into x and y components. The next step is to write Newton's law along the x-axis. I'm going to write F net x equals max. F net x is sum of the forces acting on the object along the x-axis. If I pick up the ramp as a positive direction, therefore the sum would be f cos theta, which is positive, f cos 30, which is pointing towards the positive direction of the x, minus mg sine 30. This would be pointing in the negative direction of the x-axis. That's why you have minus mg sine 30. That's equal to m times ax. If you isolate this equation for the acceleration of the box, you will have F cos 30 minus mg sine 30 divided by m. Sub in the values you have. F is 100 times cos 30 minus m is 50. If I look at m, it is 50 kilogram times 9.8, which is your g, times sine 30 degrees divided by the mass of the box. If you do the calculation using your calculator, you're going to end up getting 0.3 meters per second squared. So I didn't really need to write Newton's law along the y-axis because I only had one unknown and one equation. Therefore, I was able to find the acceleration of the box going up the ramp, which is 0.3 meters per second squared.